So here is number 1 and number 2, I guess. Number 1 and number 2. So my dark blue line, I guess that first term I didn't really simplify it. Sorry. Negative parentheses 9 minus x squared to 1/2. Second one is arcsine. Can you see what I was going for with the first two terms?
No.
One of them is a flip up, the other one is an arcsine.
Wouldn't the first one be the arcsine though?
First one is definitely not arcsine.
How is it not arcsine?
So if it was going to be arcsine, when you compared u prime to the numerator, you'd be off by a factor of x.
Yeah.
Do you want me to show more on that one?
No, I see what I did.
Okay.
You show more on the first piece of it.
On the first, the first term?
Yeah.
Yeah. So with the first term, I've got integral or antiderivative of this. I'm going to go through my list of things, right? I'm going to go ln, flip up, arcsine, arctan. And so as I go through this, there's one symbol, and honestly, one symbol only that prevents this from being a natural log. Do you know what that symbol is?
The square root.
If you take square root away, it's natural log.
Yeah.
But the square root's there, so it's not natural log. Flip up. Honestly, with flip up, to me, the best way to do it is to either mentally or literally try it and see if it works out with the whole Timmy mess up the chain rule or substitution, depending on what you do. So I would just write it out. I'd go x parentheses 9 minus x squared to the negative 1/2. And then I'd ask myself, clearly we have a composite, right? This over here is composite. And I would ask myself, is the derivative of that inside the other factor? It's close, right? It's only off by a factor of -2. And so the fact that I can multiply that outside factor by -2 and make it fit the chain rule pattern means that that's what it is. So I'd multiply the inside by -2 and squeeze in this -1/2. And then I would just use the power rule with the little box just going back inside.
And then the extra 2 comes from.
Oh yeah, so this just goes back inside. The -1/2 didn't go anywhere.
Yep.
Then it's 9 minus x squared to the positive 1/2, right? Because when I anti-differentiate, I have to add 1. But then don't I have to divide by the new exponent? So division by 1/2 is the same thing as multiplying by 2. So I usually just automatically do the copy dot flop thing, but whatever. You can do it in 2 steps if you want. Keep pondering. If something else comes up, let me know. You can tell you're thinking about something. Anybody else? Questions, thoughts, concerns on numbers 1 or 2? So for number 2, it's been a little while since in class at least we talked about number 2. Did you guys recognize that as the definition of the derivative? How many of you used L'Hopital's rule? Interesting. L'Hopital's rule works, doesn't it? So my approach was, hey, that's the definition of the derivative of secant, and I know what that is, and I just plugged in a 2. But L'Hopital's rule will work fine. Which is kind of interesting if you think about it, because doesn't L'Hopital's rule make use of the derivative?
Mm-hmm.
So you're using the derivative to prove a derivative, sort of. So using L'Hopital's a little bit circular thinking, I suppose, but you can use it here for sure.
I don't understand it at all.
I understand what at all?
Number 2.
My thinking or L'Hopital's
Well,
rule?
I tried to do L'Hopital.
Okay, so if you try L'Hopital's, right off the bat, if you do the limit of the top, don't you get secant of 2 minus secant of 2? And then if you do the limit of the denominator, you get 2 minus 2. So L'Hopital's condition has been met. And so, and I think I know probably where you're going with this, but you can tell me if I'm wrong. So now we're going to do our derivatives. And here's how the derivatives work out. For the denominator, it's obviously, this is the easier one because the derivative of x minus 2 is 1. So it'd be the limit as x approaches 2 of 1 equals 1. For the numerator, I've got to do the derivative there too. What's the derivative of secant of x?
Secant x tan x.
Yep. Okay, but then what's the derivative of secant of 2?
Zero.
So get your calculator. Isn't secant just the reciprocal of cosine? So I want you to type in your calculator 1 divided by cosine of 2. And tell me what comes out when you do that.
That's 0 because it's just a constant.
The secant of 2 is a constant. And the derivative of a constant is 0. Right? So I don't know what decimal came out of that. Tell me if you want.
Negative 2.4.
Which is a constant, and the derivative of which would be 0.
Oh.
So then this limit would equal secant of 2, tangent of 2, obviously divided by 1 is just secant of 2, tangent of 2.
Okay, yeah, that makes a lot of sense.
Okay. Okay.
How did you recognize that as the definition of the derivative?
So the first way I'm going to say it is just, it's going to sound a little bit silly, but I really am serious. It's because I am really, really well versed with this. Like I've seen this a million times, and I know that this equals f prime of c. And so then when I look at what's presented there, and I look at what I have in orange, and I compare and I say, well, this, gosh, that looks a lot like that. And this looks a lot like that. And obviously you can put them all together and say, well, gosh, that's just the derivative of f of x, and f of x is right there. So it'd be the derivative of secant, which is secant x tangent of x, evaluated at 2.
Okay.
So if you use L'Hopital's rule here, it's no big deal. I'm totally fine with it. It would be a little faster, of course, if you're just like, that's a derivative. Plug in 2, done.
Okay.
So they both work. Great questions, you guys. Keep them coming. Anything else I can do to help? Okay. So then number 3 was kind of a little bit of a beast on the algebra, like kind of on the back end with the algebra, like that final point was a little bit of a beast. And so I wanted to point out that I would say that any of these 3 answers in the box would be fine. So I don't know if you had any of those 3 versions of the answer.
Oh, you have that one.
I'd probably favor the one on the top because it's the easiest one to get to. But I think they're all pretty good.
If we just kept the negative sign out in front, is that fine?
Sorry. So if you kept the negative sign out front.
On the first one. So we have y equals negative 1.
Oh, like negative 1 over 5 halves x squared minus 11?
Yeah.
Yeah, that'd be another version. That works. Yep. I'll put that one up there. So you could have this. Yep, no problem. The orange one looks good too. Sure, we could come up with other ways. Potentially they're all okay as long as it's actually correct.
Where did you get the bottom?
Which one are we looking at?
The bottom one. The 1 or the 2 over 22.
Oh, so what I did, so I would say that like this one right here, to get to that one, what I did is I just got a common denominator between the 11 and the 5 halves.
Okay.
So essentially what I did there is I multiplied top and bottom by 2 and then combined. And then to go from here to here, I just did copy dot flop. So yeah, and I can't say that any of those is any better than the others, just different forms. They're, as long as they're equivalent, we're good. It's a little bit awkward, because like in Algebra 2, for you to leave like a fraction within a fraction was like a major sin, and I think we're okay with it. I think we're okay with it at this point. You're raising your hand, you're saying something. If you have a question, please do. All right, so that was a pretty healthy warm-up, right? A lot to think about. Whole lot to think about there for sure. Number 3 obviously being the newest of the bunch. And so hopefully this will be a good kind of segue into what we're going to do next. So I promised you, we have 2 more days here with differential equations. I promised you today the potato question. That's coming up, and then next week we'll look at what's called the landfill question. So if you would, flip over, and I want to let you know that the potato question it's on this page right here, and then there's a part C. It's over here, like on the next page. So part C goes along with the potato question there. And this might be a worthy exercise. This is actually, the first thing that you might do is actually potentially fairly tough. So there's 3 parts, right? There's A, B, and C. But only one of those 3 parts actually is what we're working on right now. The other 2 parts are complete review. So what we've been working on is finding particular solutions to differential equations, right? So it might be worth your while to look through A, B, and C and look at the wording and decide which of these, is it A, is it B, is it C? Which one am I actually finding a particular solution to a differential equation? The potato question is particularly difficult in identifying that. So consider, I'll check in with you in a little bit, but if you want to just jump into A, B, C, any of them, feel free, okay? But it might be worth your while trying to figure out which one do I actually find this solution to a differential equation. People that were unprepared for the AP test freaked out over this question. Just lost their minds. I can see why. There's some tough stuff in there. Feel free to work together, compare notes, point out keywords that you see to help you. Anything to help your classmates and you, because everybody can win. It doesn't have to just be one. Everybody figured out which question is the one where you got to find the particular solution to a differential equation? It's C. It is C. Good job. So it's pretty important because sometimes people will just do something and not even really know why they're doing it. So yeah, C is the one. So please work through as much of this as you can. I would advise that you for sure cover C since that's the newest skill. If you're looking for a smart way to order these, I would say, this is my personal opinion, I would say A is probably the easiest of the 3. B, this is my personal opinion. Doesn't mean it applies to everybody. So here's what I'm looking at. So look at what you have there, Shirley, on A. So I see that you've separated the variables. Why? Where you got to be super duper careful. There is nothing in A that tells you you should be separating the variables and doing antiderivatives and all that stuff. So what does A ask you to do? It says write an equation for the tangent line to H. So what are the 2 things you got to have to write the equation of the tangent line? And a point. So what you're attempting to do is you're trying to find the solution curve. You're trying to find the equation for the curvy thing, that goes along with H. And it does not ask you to do that. So this is why, like I asked you guys to look at C, or to figure out which one asks you to do it, because there are way too many times when students will get some question like that, and they'll see a differential equation and they just say, separate, integrate, without actually paying any attention to what the question asks you to do. So be careful. You're going to find that what you started doing with A goes along nicely with C. A is a tangent line. Please do make sure that you try C at some point. Please don't leave that for the very end and maybe run out of time. I want to make sure you at least get to C. Okay, so dH dt equals so I do disagree with one thing here. I like what you're trying to do right here. So dH dt, this would be at our point of tangency, right? And our point of tangency here is dt is 0. Looks to me like you replace dH dt with h with a 0, right?
Our H is.
So your initial condition is when t is 0, right?
H is 0 is the temperature and T is 0. Oh, that's what it is. Yeah, H is 0. That's right.
Fixing that.
So putting the 91 in there, like that makes sense. Because this will get you your slope, and it just has to do with the fact that that's an H and a T. Like if that was a T, then you would be right.
Okay, so then, that's the tangent line.
Nope.
That's just the slope.
This is the slope of the tangent.
So then would we have to do the antiderivative?
Because when you do the antiderivative, like when you start doing this, what you're looking for, like kind of the end result would be the solution curve, right? The actual curvy graph for H.
Yeah.
And in A, it's not asking for the equation of the curve, it's asking for the equation of the tangent line to the curve. So in other words, if I could show you graphically, like I don't know if this exactly looks like, let's say this is H.
Yeah. So
So that's H. This would be the tangent line at that point of tangency. So question A is asking you to find the equation of the black line. You, when you do the separate thing, separate and integrate, you're trying to find the blue curve.
So essentially the B is H.
I would usually probably use y as axis here. Yeah. That's the equation of the tangent line. And then it wants you to use that. It says, and you know that your input is a t, right? So it says, all right, well, let's estimate the temperature when t equals 3. Got it. Yes. 43. That's it. No, you're done. Oh, for B? Yeah, so this is, I think B is, so like this d squared h over dt squared is very specific. And it is a derivative, right? But it's the derivative with respect to, because it's dt squared. So it's, this goes way back actually. This is very good for us to do. So, this is the same thing as this. So you've got to differentiate this, which you already have.
Yeah.
You've got to differentiate this with respect to time.
It's like an implicit differentiation.
So there's going to be an implicit differentiation. It's going to show up. That's right. And that'll make a little difference, for sure. So obviously, you all know that our class is done at 25 after. I really, really, really want you to try C. Please don't leave C for the end and say, oh, I never got to it. Did you do this for me? Okay, okay, let's see here. So, what are tangency, slope of tangent line? Let's see here. So, your slope, oh, yeah, you're very close. You are this way, so this here. Okay, so I like this, and I like that we were trying to use this to get this. See? It is. It totally is. The only problem I'm going to have is this. So to me, it looks like we need to replace the H. You know your equation. I got a small some DH. That's like equal to 0. So I need to find your slope. Yes, because this is an H.
terrible. But notice this says for T.
Oh, wait a minute. You showed them you had arrows twice.
That's not sure.
Not sure. And then you need to find your pounds at the matches on because why don't it's just
I should probably use square root of T.
I think so.
Sorry. I'm just reading it upside down. So an alternative model for the internal potato. I'm gonna have a problem with this. This is not gonna be right. It says one phrase in here. There's one phrase in here. That's what I'm debating. I'm not debating about that actually right now. There's one phrase in the it says find an expression. So at some point in here, you need to have GOT equals. Yeah, so this is where you can do your separate and integrate. Let's do that. Let's do the whole separate and integrate thing, and then let's compare this answer to your answer, and see how it would all work out. Let's see if this was a. You guys are thinking so good. What's up? Cube both sides. Why is there a negative there? When you integrate. Once you integrate, you're gonna have a T. But there's no negative on the exponent. So yeah, you can't do that, which will change. Obviously, we'll like filter on through the rest of it. Yeah.
Why don't you have to divide by? Oh, yeah. Because you would have to divide and then
Okay, so you're talking about after the separation, yeah. Okay, gotcha. So let's look at that. Sorry. Put that back in. DG over.
if you do that, you have this thing on this side.
You should just use negative 1/3. This should be negative 2/3. Right? This gets flipped down. That'll change. Yeah, that'll be. The right concept though. I mean, separation rules are great. This is good. Yeah. Worthy question, right?
No, you're gonna get rid of that. You have to keep if it was a square, we're gonna get a square.
So what are we doing? Take it.
Get rid of that one.
How do I do this?
So it's the same thing.
So there is, I bet I'm going to resize here. There's C. So please just take note of the steps that I've got up there. I've got separate. I'm usually a pretty good speller, but separate always gives me a hard time. I can never remember if it's SEPE or SEPA. SEPA, isn't it? Separate? Yeah. So I separated, I integrated, found my antiderivatives there, plugged in, initial condition. Yeah, so it looked like something is different there, Isabel, with that final answer compared to the first one that you were proposing. Found my C, had it put in there, and then plugged in the 3. You all are very, very quiet. Have any questions? Can I do to help? So I have a fun fact for you. I think, question, Isabel, go ahead.
Why is it negative dt?
So when I separated my variables, so of course, negative dt is really negative 1 dt. So I could have very easily moved that negative 1 over with the g minus 27. I could have moved it over there. What I typically do is I'm going to move as little as possible over to the g side, because I know in the end, aren't I going to solve for g? So I figure the less I bring over there, the less I have to take back over in the end. So if you would have brought the negative over, it could still work out just fine. You'd get, instead of a 3, you'd get a negative 3. And instead of a negative t, it'd be a positive t on the right side. And your c would look a little bit weird. In fact, Merrick and Hunter were looking at that. Did it work out the same way for you guys?
Yeah.
Okay, yeah, it should. Isabel, go ahead.
I got negative 12 first.
Yeah, so it'll work out totally fine. So if you, let me see if I can, I'll just go in here and change this. So if I had this and this, it would be this and this, right? I'm just changing all these. So then it would be here and here. So then it would be here. But then it would be here and here, right? But I'd get the same thing if I just divided through by the, wait, hang on, it should be here. There we go. Yeah. So when I divide through by that negative 3, instead of dividing by positive 3, you'll get the same thing. So depending on how, like, little tweaks in how we order things, our C's might look a little bit different in between. In the end, they should all be the same. Should all be the same. Any other questions on that one? Let me offer you some encouragement. So all of this is right off of an AP test, like I told you. All the AP free response questions are worth 9 points. And we get statistics on these all the time. This question right here was worth, I believe, 5 of the 9 points. So pretty significant, right? So, if you got, and we've talked a little bit about how the points work out and everything. So this might be fascinating for you to hear. The average score on the whole question, parts A, B, and C, not just C, but the whole question, the average score was slightly over 2. So terrible, 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 terrible. So if you got all of C correct, you just 2.5 times the average for the whole question. I say this should be an encouragement to you, because even if you totally messed this one up and only got 1 or 2 points, you're ahead of the game. You're ahead of the average for sure. And we only have, almost 3 months for you to get better. So be encouraged. If you're doing okay with this, I think you should feel encouraged. Let me show you a couple of more. Here is A. So A asked for the equation of a tangent line. It did not ask for a solution curve. It did not ask you to separate the variables and find the particular solution. It just said, it's right there in the very first couple of words. It said, write an equation for the tangent line to the graph of h at t equals 0. So let's be honest. If your answer in the end isn't a line, categorically you did the wrong thing. And that makes sense. It better be some version of y equals mx plus b. Or I did y equals mt plus b. Yes, sir.
Is it okay if we just left it at point slope?
Absolutely.
Okay.
Yep.
We don't have to go that extra
Nope. I would say, I don't even know why I did what I did, to be honest with you. I would leave it at point slope. I guess probably I did it that way because it was super duper easy to get slope intercept. Sometimes it's not. So then once you use that tangent line, I got 43 for the estimate for h of 3. I was pointing this out to these guys up front here. Part A, basically what we have here is we have some curve. It's called h. Part A was not asking you to find the equation of the blue curve. It was asking you to find the equation of the black tangent line. And then we're using the tangent line to approximate the blue curve. Any questions on A? So then it could be debated that B is the toughest, which you wouldn't think it would be, but let's see what you think after this. So it said use d squared h over dt squared to do stuff. And so you got to find d squared h over dt squared. A lot of people forgot this, and we can discuss why that needs to be there. Because once you have that, you can figure out a numerical solution pretty quick, and you can find out that H is concave up, and so any tangent lines would be too low or an underestimate. We can talk about any of those pieces. Did anybody have d squared h over dt squared just equals negative 1/4? And that's it? Yeah. So that was the number one most common error. So let's talk about why this is. So dh dt equals negative 1/4 times, is it h minus 27 to the, what is it? And that's it? Just that? Okay, cool. So then it asks you to find or use this. And you can see I was writing this up on the board. I'll write it again. This is equivalent to ddt of dh dt. I don't know if you can remember, but way back in like September, we had this whole page of derivative notations. Like, what does this thing mean, and what does that thing mean, and so on and so forth. And this is kind of going back to that. D squared h over dt squared doesn't just mean the second derivative. It means the second derivative taken with respect to time, not h. And so when I do ddt, I'll put this in a different color. If I do ddt to this and ddt to that, over here I naturally get what I'm looking for. But on the right, I got to be honest and realize there's a chain rule, right? Because aren't I doing ddt of an h? Ddt of an h. So it would be negative 1/4 for sure. But then the derivative of the actual inside derivative of the variable, if you will, would be dh dt because of the chain rule. And then, what's dh dt? Well, we already know that. Isn't dh dt just this? I'm replacing this with what it really is, which gives me positive 1/16 times h minus 27. And we know that h is always bigger than 27. Doesn't it say something about that? H is bigger than 27 the whole time? Correct? Yes? So if h is always bigger than 27, h minus 27 would always be positive, making the second derivative with respect to time always positive. So h is concave up, therefore tangent lines are always below, so it's an underestimate. Tough question. Can you see why the world average was like 2? There's a lot going on. Merrick.
Why is it an underestimate?
So this right here, we're told that in the question stem that h is always greater than 27.
Yeah.
Apparently room temperature is 27, I guess. So if h is always bigger than 27, that means h minus 27 will always be positive. So this right here, the second derivative here, will always be positive. And if the second derivative is positive, doesn't that mean the graph of h is always concave up? And if the graph of h is concave up, that means any tangent lines drawn to the graph of h, I'm trying to sketch it in here, will be, oh man, this is tougher than it looks. Jumping around. Can you see how my tangent line is supposed to be below?
Yeah.
It's jumping all over the place, but yeah, kind of tough to do there. All right, that would be it. I hope you have a wonderful weekend. When I see you on Monday, we'll not Monday, Tuesday, we'll be gathering at the landfill problem. Thank you, guys.
Do you have 30 seconds to go to this one? I cannot figure out
Sure.
how to get there.